Hello everyone! In this tutorial, we will work with the data frame that we have previously processed, which contains the information of the P48 program generation for all these technologies and indicators. The goal is nothing more than to emulate the chart that the electric grid has on this web page, where each vertical bar is composed of each of the indicators that we see here on the left, for each day of December from the 1st to the 31st. However, in my frame, the data are hourly. At 12 at 11, I would need to process the information to obtain the daily generation for each of these indicators.
Therefore, if we use the resample function, as we have a time index, we can indicate the rule parameter, which means we want to perform operations for each day.
Then, this function will take all the rows that belong to the same day and will sum them up, in such a way that when I apply the sum, I have the generation for each of the indicators for December until December, which was yesterday. Let's save this data frame in a variable df generation daily for daily. And to compare the data, we can see that hydraulics has 85,000 for December 1st. If we come here to the ESIOS page in the table, hydraulics has 85,000 for December 1st. Now we would proceed to make the bar chart with the Plotly library. Therefore, we import the library and look for the bar function. It asks us for the data frame in the first parameter. We give it DataFrame equal to df generation daily. However, it's only asking for an x column and a y column, but I have several columns that I want to use in there. How could we solve this problem? Let me explain with a simple example. We're going to load some data with the Pandas library, the CSV file I have with Titanic information, and associate it to a variable. When I want to make the bar chart, it asks for the data frame. I can give it df Titanic. In X, I give, for example, survived. And in Y, I tell it the height of the bar, which is the frequency of people who died on the Titanic, whether male or female. Execute. Here I get the bars. If I want to differentiate the color, I say here color and put the column sex. Execute, and it differentiates by colors just as they are differentiated on the ESIOS page. Well, now we must understand how the bar function has processed the data from the df Titanic data frame. If you look at the x-axis, we have 0 and 1, and here in the data frame, we have it in the column, and all those rows say 0, 1. For the frequency column, likewise, we have the values of people who survived or not based on sex, which is another column, and it's differentiating the color here. So, how could we make our data frame, which is for daily generation, resemble the one we have here from the Titanic? We would need to use the melt function. And when executed, it places each of the technologies in the rows. That is, it's a function that melts the data frame. The columns become rows. However, I lost the time information so that this doesn't happen as time is in the index. There's a parameter. It's called ignore index, which by default ignores it. Therefore, I should tell it not to ignore it. False. And now I keep the index here. I take these functions to the next section. We do the melt. I'm going to reset the index so that datetime is put at the same level as the columns. Therefore, reset index, execute, and save this object in the variable DFRes. Now let's proceed to visualize the data in the same way we did previously with the Titanic. If I say DFRes, which is the data frame that I have up here, on the x-axis horizontally, I want the dates, therefore, datetime UTC the days, just as we have here on the ESIOS page. And on the y-axis, I want the height of the bars determined by the value column. And then, in each bar, I want to differentiate by colors the type of technology which is in the variable column. Therefore, color equals variable, execute. And here we have a visualization that goes up to 800,000 megawatts per hour, as we can see. In this chart from the ESIOS page at 800,000 megawatts per hour. Though, if we wanted to improve the visualization so that, for example, at the bottom appear the technologies that generate more energy, we could go to the data frame DFRes and tell it to order the values according to value. And here, I save it in the variable DFRes again and execute, though the ones that generate the most appear at the very top. If I want to do it the other way around, I put ascending equal to false, which by default is true. As we can see here, execute again. And now we see horizontally, From 0, the technology that has generated the most in this entire period on a given day is wind, followed by combined cycle, which is gas, then nuclear, and then hydraulics. This would not be the only way I have to visualize the data. If I want to go further, I could use facets, which is a parameter that allows me to create a different chart for each value of the columns that I give it. In this case, I give it variable. In variable, I have each technology, so it will make a chart for each technology. Many appear in the same row. Therefore, I'm going to use another parameter called facet colwrap, and I'm going to tell it that I want 4 charts per row, and here I have them all. I want a bit more height in the whole chart, therefore height equal to 700. Execute, and here we see a more aesthetic representation of the data, where wind technology generates the most energy, as we previously mentioned. Only now, in my opinion, the whole chart looks better, because each one differentiates the technology. But in these matters, to each their own. Alright, let's make an area chart instead of bars. I can copy that cell here. And instead of using the bar function, use the area function. Execute, and here we have the information as before but represented in another way. I could do the same with facets. I bring it below and tell it area. Execute, and here we have another way of representing the data, which in my opinion, I like more. So, that's it. I hope you have understood how, with the raw data that we have generated previously, we have to do a bit of reprocessing to have the daily information thanks to the index that is temporal. However, having a data frame extended horizontally, we could not automatically perform the bar function to differentiate the color. And in this case, we had to use the melt function to melt the data so that the columns become rows of a single variable that we then used to differentiate the color of each technology. And that, as always, everything related to programming and data can be automated. Here, this chart that we see on the ESIOS website, we have been able to perfectly simulate in Python, as we can see in this chart. Alright, now it's your turn. Practice, give it your all, so that you get a good grasp of the coding habits and ideas that I have been demonstrating in this tutorial. And if you have any questions, suggestions about the materials, let me know in a comment and I'll be happy to respond. Now cheer up and get to it.